I'd like to pick up where we left off yesterday with talking about. Remember, we talked about quantitative and qualitative uh, data. Okay, and if we think about it, we can create a structure. We can create kind of a flow chart of our data, where you just have our overall data, and it's going to be broken down into two categories: quantitative. So quantitative, we're thinking numbers, right? Okay, things that have been counted or measured. And then we've got qualitative. And there you're thinking about categorical things, things that are like describers of something, okay? One thing we talk about a lot with qualitative data is like gender or ethnicity, religion, okay? There's a lot of things like that, and we can get very kind of bland with it, and you talk about like eye color, hair color, that kind of stuff. But those are all qualities. Those are descriptions of something, right? They're words, okay? And they're not terrible to have. They're hard to do statistical analysis with, but we can. And if we get through enough of the course, we'll start talking about like structures of research and how if I do research that's just qualitative, it might be decent research. If I do research that is just quantitative, it might be pretty good research. In my opinion, I would rather have quantitative research and data than qualitative. But if I can maybe merge the two in my research, then that I think becomes very useful, very informative. Okay, quantitative then breaks down further to what we refer to as discrete or continuous. Okay, discrete just means that we were able to count to generate our quantity, and continuous means we were able to measure to develop our quantity. All right. A lot of times when we're talking about like continuous is that values are like they're measured on a scale. Okay. Now when I say scale, not necessarily meaning like a weight scale. It could be like a distance, so measuring on like a ruler or a tape measure, that kind of thing. That could be a scale. But our continuous is going to incorporate fractions and decimals and those types of things. Okay, discrete, just whole numbers, because that's how we count. Okay, so if I'm looking at these examples, so this is kind of what I'll do tomorrow in some fashion, is I'll give you some scenarios and ask you identify this as discrete or quantitative or qualitative, and then if it's quantitative, I'll ask you to go a little bit further and say, okay, well, it's discrete or continuous. Okay, so A there says the number of pairs of shoes you own. Is that quantitative or qualitative? Quantitative, okay? And if it's quantitative, is it discrete or is it continuous? Discrete, okay? You can only have whole numbers, right? Okay. Now, last class I argued, well, what if I lose a shoe? The argument is if I lose a shoe, I no longer own a pair of shoes. I just have a shoe. It doesn't get categorized, right? Does that make sense? What if the question was the types or brands of shoes you own? What would that be? Would that be quantitative or would that be qualitative? Qualitative. Okay. So if I say, I've got Adidas, Reebok, Nike, that kind of stuff, those are descriptive or descriptions of the types of shoes I have. And that's kind of what we see there in part B, the type of car you drive. Okay, so if I drive a Honda or a Jeep or a Lexus or an Accord or something like that, okay, those are types of cars, right? Are those quantitative or qualitative? Qualitative, okay? The distance it is from your home to the nearest grocery store. Quantitative, it's going to be a number, right? Now, can anybody just live exactly 3 miles or exactly 4 miles or exactly 5 miles from a store? You could, but can people, like, does that mean that every single person in the world ever to exist and ever that will exist can only live at those distances from the store? No, you could live 2.23 miles from a store, right? So is it discrete or continuous? Continuous. What about the number of classes you take per school year? Quantitative, discrete, okay? Has to be a whole number of courses, okay? Type of calculator you use? Qualitative, okay? Weights of sumo wrestlers? Quantitative, discrete, or continuous? It is continuous. So sumo wrestlers don't weigh just like 320 pounds, right? They're going to weigh 320 point whatever, okay? So that's going to be continuous. Number of correct answers on a quiz. Quantitative, discrete. And something like this, guys, especially when we're doing the research on our own, we might have to describe in our research what we mean. We will have to define what we mean by correct answer, okay? Because you guys are all, if somebody in the first period said, well, what, you give partial credit. Okay, but is that really a correct answer? Correct answer means you got it all right, correct? Okay, so I'm not getting half an answer right, half an answer wrong, that kind of thing. Correct answer, all right. So you can only have whole number correct answers on a quiz. So that would be discrete data. IQ scores. I don't know if you know IQ scores. IQ scores are reported as whole numbers. Okay, they are not reported. You can't have like a 120.5 or something like that. Okay, so an IQ score is going to be quantitative, discrete. Is that cool? Okay. When we look at the next image here, how would you, it just says the following graph shows information about a local school district. Identify the type of data. From just what we're given there, what do you think that data is? Is it continuous? Is it descriptive? Or sorry, quantitative? So being numerical, or is it qualitative, being more descriptive? And I don't know that you could be wrong here. Why would you say qualitative? Okay, so directly looking at it, and I would agree, I would lean more towards qualitative because there are no numerical values up there for me to interpret. So we're looking at a population of students, and basically we're able to see it broken down into their descriptive natures of freshman, sophomore, junior, senior, right? Okay. We've also argued in the last class that we could go quantitative, okay, because we know, like, we can justify that they came from a population, and looking at the size in the chart, we could maybe attach a quantity to them. Does that make sense? Or project that they came from, the only way that I can really make that table, that pie chart, is if I knew what the actual quantities of freshmen were, sophomore, junior, and senior, right? So their argument was, well, it's quantitative, and it'd be quantitative discrete, okay, because you can't have half a sophomore, half a junior, something like that. And they argue that it was that way because they just haven't provided us the data. Does that make sense? Or knowledge that the data existed. Those are things that when we are personally doing the research, we would kind of identify all that information prior. You guys have done research papers in like an English class where you like research based on like reading other documents and then putting ideas together and that kind of stuff. But if you're doing like a legitimate like research, you hear people say that they're going to go get their master's degree or they're getting their PhD and they're writing like a dissertation or a research paper or something like that. What they are doing, they're actually conducting an experiment and then recording data, collecting data, and then doing like hypotheses testing on those, and then developing their conclusion. Okay, in that type of research setting, what you would do, one of the first things you do is you identify all the vocabulary that you're going to be using through there and all the ideas and concepts that you're going to be using through there. And that might be something that you go through and explain that, this is going to be quantitative data or this is going to be qualitative data. Does that make sense? Okay. Again, maybe not something that we get into depending on time. It's been a long time since I've taught this class. I've never taught it under the guise of a university, so Rhodes, their curriculum is a little bit different than what it was when I taught it, just as high school credit. So that might allow for some time at the end of the year to actually do some investigation of research papers. Okay, so we might do that. Graphing and displaying qualitative data. Okay, so we're talking about there's two branches of statistics we talked about. There's inferential statistics, which we're not going to get to until later, but it's using probability. And there's descriptive statistics, which is collecting the data, organizing it, presenting it, and summarizing it. Okay, this stuff here is how we display qualitative data in descriptive statistics. Okay, so we got a couple options here early on in the text. These are the three that they talk about and the three that you see the most. But when I said at the beginning of class where we're going to eventually start doing some calculations and that type of stuff, the early on stuff is going to incorporate developing the standard way of creating a histogram, the standard way of creating stem and leaf plots, the standard way of box and whisker plots, and those types of things. So that's kind of where we'll start off with our calculations. But pie charts, bar graphs, and Pareto charts are the first three ways of displaying qualitative data. It says categories of data are represented by wedges in a circle and are proportional in size to the percent of individuals in each category. Okay, so we would collect data about somebody or something, a population, and then when we display it in front of people, we are displaying it as the quality, okay, or qualitative aspect of the data. So here we're talking about the qualitative aspect is whether somebody is part-time or full-time, okay. Now, I earn or I develop percentages of those people in the population, but they fall in those ranges based, or those positions on the graph based on the quality, the description of their employment. Does that make sense? Why that would be a qualitative piece of data, okay? Or I guess each one of those is a qualitative piece of data that would be in here, each person. If we talk, so that's a pie chart. A bar graph, you guys have dealt with bar graphs since like the third grade. They can be vertical, like the one we see there, or they can be horizontal. Every time you do a bar graph, you're going to have an axis, whether it be the y or x-axis, that is numerical, okay? And then the other axis is going to be your categories, okay? So here we see our x-axis is our categories of students that are full-time and part-time. So this information that we see here in the pie chart is the exact same information that we see here in the bar graph, okay? It's just presented differently, and at certain times it might be, if you are trying to persuade somebody over something, maybe the pie chart is a better choice than what the bar graph is. If you're doing a bar graph where it's horizontal, so your bars are going from left to right, usually your x-axis usually has something to do with time, and then your categories would be on the y-axis, okay? This is, I don't know if you guys ever heard of a Pareto chart. A Pareto chart, simply a bar graph again, but it just orders things, or it orders the categories from largest to smallest. So it allows the observer to quickly compare things by just a quick glance at the graph. So looking at that right away, without even looking at the numbers, okay, let's talk about ethnicity of students at this certain university or whatever, more Asian than anyone or any other ethnicity, and then there's a drastic difference we can see between Asian and Native American. Does that kind of make sense? So Pareto chart is designed to give that initial ordering for the observer. Okay, and that's something to do with statistics, with descriptive statistics. We want to be the people when we're creating. We want to be the people that takes all the fault out of the kind of the analyzing that the spectator or the audience is going to have. We don't want the audience to have to sit down and do a lot of, number crunching and that kind of stuff to gain the information. All right. But again, like I said early on, we're doing vocabulary. We'll come back to all this stuff, and I'll teach you how to structure and generate these things. We also have the ability to use Excel and Google Sheets, and there's other programs where you can essentially just enter your data, enter your qualities, okay, or your categories, whatever they may be, if it's quantitative or qualitative, that kind of stuff, and you can just select that, and then the programs are built to where you can just say, okay, now I want this information to be constructed into a pie chart, and it'll automatically make a pie chart for you. Or I want it to be a Pareto chart, and it'll automatically do it for you. Okay, so we use some of that because I think as you guys get into other classes in which you use statistics, you're not going to want to sit down. If I'm in a nursing course and I have to do some statistic stuff, or maybe in a my wife is a speech therapist and she had to take stats, and she's still in her job does a lot of statistics. If I want to interpret like standardized testing scores for certain patients, and how they're performing in regards to their therapies, I don't want to have to sit down and chart things out, graph things out like we would in a stats class. Does that make sense? I want to be able to use Excel or Google Sheets or maybe the program that my facility lets me use, where I can just type the data in, click this button, and it gives me the chart, and now I can compare that stuff. Does that make sense? So we'll try to learn how to use some of those things throughout the year as well. All right. The key thing I want to talk about today is sampling. Okay, this is huge. This is probably the most important thing beyond. Well, I don't want to say beyond anything. This is probably the most important thing that we are going to have to understand before we can move any further in the course. Okay, sampling is something that every single study that we do is going to incorporate sampling, and if our sampling is done poorly, that already at the onset undermines my entire research and kind of nullifies any conclusions that I might be making. Okay, so sampling talks about gathering information about an entire population is usually too expensive or logistically impossible. That's something that we cannot do. Okay, now if you guys were the entire population, this class of 20 people, entire population, and I wanted to learn something about you guys, I could easily logistically talk to every one of you and get the information I need. Does that make sense? But if the population was the entire high school student population, it might not be feasible for me to be able to talk to every single student in the time frame that I need, and it might be too expensive to do that. Okay, in terms of time and money, might not have enough researchers to do it. So what I would do then is I would sample this class. Does that make sense? Okay. Now, think about this. If I want to know something about the entire school population, would this class be a good choice to sample? Why not? Say again? Okay. So you guys all share similar characteristics, right? Okay. You're juniors and seniors, okay? You're on a lot of you are taking college credit, so you have maybe kind of a very similar set of characteristics that distinguish you and make you different than the entire population, right? So what we want to make sure of when we sample somebody or create a sample is that we make sure that the sample shares the same characteristics as the population. Okay, so therefore we use sample of the population, which then in turn allows us to make conclusions or inferences about the population. That's why we do a sample. It's easier to investigate smaller groups and then use those smaller groups, the results we get, to make inferences about the population. But if we choose a group that doesn't have the same characteristics as the population, then that information about that smaller group isn't paralleling to the population. Does that make sense? Okay. All right. So some key terms in doing this. The first one is random sampling. Okay, this is kind of the overall category. So when we're making our flow chart, we got random sampling at the top, and then there's going to be versions of that below it. Okay, and versions of types of sampling below it. But random sampling is sampling in which each member of the population has an equal chance of being selected for the sample. Okay? Every person in the population has an equal chance of being selected for the population. From the population for the sample. So there are several random sampling methods, and each have their own inherent pros and cons. First of all, let's just talk about what it means to be equally likely. Okay? If I flip a coin, what are my chances for that coin to land up? What are my options? Flipping a coin. Heads or tails, right? Okay, and theoretically, we should assume 50% heads, 50% tails, right? So when I flip that coin, it is equally likely to occur heads as it is tails, right? Well, if you guys are the population, 20 people in here are population, I'm going to choose 3 of you to be my sample. Each one of those people in the sample should have an equally likely chance of being in the sample as anybody else in the population. Does that make sense? So Lucas, his probability of being in the sample should be 1 out of 20, right? Does that make sense? Bella should be 1 out of 20. Peyton better be 1 out of 20. Does that make sense, everybody? Okay. If Lucas's chances of being in that sample is 1 out of 10, but everybody else is 1 out of 20, that's a problem. We got some error there. Okay, we need to adjust for that and address it. What we refer to as simple random sampling. Okay, simple random sampling. That's exactly what it is. It's going to be simple. Okay, should be pretty straightforward. I'll show you some different techniques on how we do this. But a simple random sample is a set of n objects. So in our statistical analysis and our formulas, and we'll talk about this when we start seeing specific formulas, but lowercase letters a lot of times refer to the sample, okay? And then capital letters, because they're bigger, usually attach themselves to the population. Does that make sense? So lowercase n here is a number of objects that we're going to sample, but they come from capital N, which is the number of objects in a population, okay? All the things that are possible to be in our sample, okay? And this is how we would do this. And I got to do a quick Google search because I lost it since first period. All right, so it's going to be a random numbers table, okay? And they all look like this, okay? Now, you can do a Google search, you can start comparing different random number tables, but basically what they end up being is 5-digit numbers that are just random, and they're in columns and rows like this, okay? So let's say that we've got 25 people in a population, 25 people in a population, and I want to sample 5 of them, okay? This is how a simple random sample and the use of a random numbers table works. If I have 25 people in the population, what we're going to do is we're going to identify each of those people with a number. And the easiest thing to do is just to identify them. Like, I would take their names, put them maybe alphabetical or whatever, put them in a roster, and then I would just attach to each one of those names a number in, we're really having trouble here, in ascending order. So I would name, maybe Lucas is 01, maybe Jenna is 02, and we keep going because I've got my population is a 2-digit number, right? Okay, so everything that is below that has to be a 2-digit number. So if there's actual single-digit numbers, you put the 0 in front of it. If I had 100 people, in my population or 200 people, whatever, my first person would be like 001. My second one would be 002. Does that make sense? So we'll keep doing that. I won't do this all the way out. But we would do that all the way down to 25, okay? So each one of these numbers has now an individual attached to it, okay? The next thing you're going to do is you're going to look at your table. And you're going to just, you read your table left to right, and you're going to go all the way through the first row, even though there's gaps and all that kind of stuff. You're going to go through the first row, and once you get to the end of it, you're going to then jump down to the second row and keep going. First thing you're going to do is you're going to, because we're looking for 5 people, and we've got 2-digit numbers, so we're going to just look at groupings of 2-digit numbers. So that first one, I'm going to look at 61. And I'm going to record that number. So I'm just going to write down here, 61. And then I'm going to go to the next set of 2-digit numbers, which is 42, right? And this is where it's kind of weird, but I'm going to go to the next 2-digit numbers, which are those two. Does that make sense? Which is 42 again. And now I'm going to go to the next set of 2-digit numbers, which is 04. 04 is that one of the items that I have over in the left-hand column, one of the, essentially the people that were in the population, right? So 04, that person just got selected to be in the sample, okay? And I keep doing that process of checking 2-digit numbers. So the next one's 19. Would be 19 be in here? So I would choose the person attached to number 19. 86, don't have one of those. 54, don't have one of those. 60, don't have one of those. 05, we have one of those. We have a 17. Okay? So then the next one would be, so there's 90, and then the last one, we'll pick off 22. So these then would be the 5 people that get chosen out of the 25. That make sense? That eliminates any potential bias. If I were to see names of 25 people and I had the choice then to choose the sample, whether I consciously or subconsciously do it, there's going to be bias in that. Are we okay with that idea? Okay. This eliminates that. Now, that can be a pain in the butt, and if you want to do something like this, you're going to have a table of random numbers on you. Obviously not hard. Google search can get one. But have you guys ever used Excel? Okay, so Excel or Google Sheets, they're both very similar. Obviously, Google Sheets made by Google, Excel, Microsoft. They're a little bit different in the commands that we use or the commands that are offered or available. I like Excel because I learned spreadsheet stuff and statistics with Excel when I was in school. But Google Sheets, I think, is obviously you can share them, you can edit them, they save automatically and all that kind of stuff. So they're a benefit as well. And Google Sheets doesn't freeze like that. Okay. So let's go to, I'm just going to view something here for you real quick. We'll zoom. Okay. So what Excel does, I don't know how experienced you guys are with Excel, but I'll give you some scenarios of some non-statistical features that Excel has. So let's say that we're going to add up your course grades, and we had all your assignments. So let's say that we got like 23 points, 12 points, 36 points, 45 points, 12 points, again, 14, 78, and I want to add all those up, okay? Well, I can add those all up. I can just hit the equal sign. When I hit the equal sign on Excel, what it does is it jumps me into all the functions that Excel has, all the formulas and stuff like that that are built into it. And we can also, with Excel, they're called macros, but we can kind of create our own, which is really neat. But if I type in sum, okay, what it's going to do is ask me, well, what do you want to sum? Well, right now I want to sum everything from A1 to A7, okay? And what kind of stinks is to learn Excel, you got to learn all the different syntax and notations that they ask. But here, it automatically adds all that stuff up, okay? And now,
What's awesome is I could say, well, okay, well, go back to the assignment that was worth 12 points. I just doubled the quantity, hit enter, and now automatically changes the 220 to 232. Okay, so that's kind of the benefit. I think Excel, a lot of people just use it to like create a spreadsheet or a roster of names, or people use it to do finances at home, but they don't really use it with its built-in functions. I'm going to try to teach you some of that stuff in stats. One of the built-in functions is a random number generator. So what we can do is we hit R or equals and then type in rand. And if I just type in rand, okay, and close the parentheses like that, what it's going to do is just generate a random decimal, okay, between 0 and 1. There are certain applications that might be useful for, but we don't want, we haven't named our people in our population by decimals like that, right? So we want integers. So the rand between option is really what we'd be looking for, okay? And we're going to go from, we got 25 people, so I'm going to go, I want the first person, comma, up to the 25th person. And what's nice, I know you're far away, but you guys see this gray little box here? When you start typing in functions, it will tell you the types of things that you need to put in these parentheses to get the function to work right. So it says bottom, and then it says top. So I need to know what the bottom value is, and you know what the top value is. I hit enter, and it just randomly generates a number between 1 and 25. So 22 is that number. Now, let's say I wanted 5 people. I can just click and drag, and it copies that formula in each one of those boxes, and now I've got my 5 people that I need to go choose. Does that kind of make sense? Okay. And if I want to do it again, we just generate another, I guess there's 6 there, but you can keep regenerating them as fast as you can. That's much more efficient than using a numbers table. Your TI-83, 84 has the same capacity. It's a little bit messier, but it does have a lot of statistical stuff built into it. If you go to math and then go over to the top where it says PRB, you see where it says rand. Now there's rand, but I want rand int, random integer is what it's saying. Okay, and I'm going to set it. Basically, we set it up the same way. It wants your low value, and then it wants your high value. And I can hit enter. And what's nice about that, then, if I want 5 of them, just keep hitting enter, and give you as many as you want. Does that make sense? Okay. If I do the same thing, but put a comma, so bottom number 1, top number 25, and let's say I want 5 numbers chosen or created, it will create those 5 for me that way, so I don't have to hit enter 5 times. But those are relatively new technologies that, you know, when statistics, you know, we've been using statistics forever. You know, think about the computer and the calculator. They're only around since like the 70s, okay? And the capacity that they've been used in statistical research is not a long amount of time. Does that make sense? So the number table, the random number table is what was being used before then, okay? Is everybody cool with that? Okay. So there's a couple other techniques that we talk about that might help with the sampling process, but there might be some issues with these. Like we said, there's pros and cons to them. Okay. One of them is called stratified sampling. Okay. Stratified means you're going to break things up into groups, but they're already predefined groups for us. So it says divide the population into groups called strata, and then take a proportionate number from each stratum. Okay? So what that means, let's say I want to survey the high school student population. Is the high school student population already, by the way we do things, broken up into groups? Freshmen, sophomore, junior, seniors, right? Okay. Now, let's say that we had a group, I think it says up there one in the scenario. Let's say we have the sophomores are twice as big as any other group. I would then want to make sure if I've determined that I'm going to take 10 people out of every stratum, then I better take 20 out of the sophomores because its population was twice as big as everybody else, right? Remember, we want our sample to have same characteristics as the population. So the sophomores, because they dominate the population, they better kind of almost dominate my sample, right? They need to be represented proportionally in there. So that's what happens is that you divide up into the stratas and then sample out of them. So if I go freshman, I'm going to do then a simple random sample out of the freshmen. Then we'll do a simple random sample out of the sophomores, a simple random sample out of the juniors, and then the seniors, and then that creates my overall sample. Does that make sense? So that's stratified, okay? Now we have what's called a cluster sample as well, okay? And that is, it's very similar. It says divide the population into clusters or groups, and then randomly select some of the clusters, okay? Stratified meant that I was going to break them up into 4, 5, 6 stratas or whatever, and then go into each one of those clusters and pick out a small group out of each one of those clusters. Does that make sense? Or stratas, okay? Cluster sampling means I'm going to take the population and I'm going to break it up into freshmen, sophomore, juniors, seniors, and then I'm going to choose one of those groups to be my sample. So maybe I choose seniors to be my sample. Does that make sense? That's a little bit different than stratified sample. Now, if I pick my seniors, is that going to be a good representation of my population, or my high school population? No, right? Okay. Now let's think about this group. Let's say that I take this row and you're my cluster. Well, you're one cluster. Take this row, you're my cluster. This row here, cluster. And then you three, my last cluster. Okay. And then I take this row here to be my sample. Would that be okay? Yeah, that makes more sense because, again, the population in this room, you all have similar characteristics. If I break you up in clusters and choose this cluster, what's to say that this cluster is going to be drastically different than that cluster or that one or that one? Does that make sense? Okay. So cluster is a little bit different. They're similar concepts, but it's how I then choose what to do with those groups. Okay. The one here we've talked about a lot, okay? Systematic sampling. Systematic sampling means that you are going to start by choosing a first object, and then you're going to choose every nth object after that to become your sample. So if I want to do like a phone survey, I want to know what people in Allen County think. I'm going to get the Allen County phone book, and I'm going to close my eyes, and I'm going to turn the page. I'm going to put my finger on the page, and that's the first person I call. And then I've probably already decided, okay, I'm now going to call every 200th person in that list. You see how that's pretty random? I count 200 people, call the next person. Count another 200 people, call that person. And I keep doing that all the way through the phone book and then all the way back to the beginning and keep going all the way through until I reach the number of people that I want in my sample. Okay? Manufacturing does that. P&G, they're not going to take every single jug of detergent and measure it. They're going to take every 30th or every 40th jug and measure it. Does that make sense? So collectively, they're systematically finding a sample of their product and determining variances and stuff like that in those products. Okay? Stop there. Tomorrow on your quiz, the furthest we get with vocabulary is down to simple random sampling. So no random sampling, what that is, and simple random sampling, those end up being there, but nothing below that on these notes shows up on the quiz. Okay? Quiz shouldn't take you the whole period. I'm going to just judging trying to judge time on quizzes and stuff like that, I will give you the whole period and just kind of see where we're at, and it'll allow me to make judgments about the next one I have. No homework yet. Okay, I'll leave that unassigned.